Okay, so for this transformation, what's the rank of the matrix? What's the maximum rank it could possibly have? If you reduce this matrix, what's one thing you can definitely tell me about the reduced matrix?
It'll have a row of zeros.
It's going to have a row of zeros. These zeros are going to be there, right? Okay? So, with this matrix, we'll either reduce down to the identity or the first row with the row of zeros here. Okay? If you got a row of zeros already, then you got a row of zeros, right? And if you don't, you're going to get one here because you're going to have the identity up here. It's going to wipe everything out. Okay? Now you got to be familiar enough with matrix reduction to understand what I just said. I hope you are. If you haven't practiced enough, you might have to think about that a little bit, but we need to move on. Okay? So the rank less than or equal to 2. Okay? Nullity. What can you tell me about the nullity?
Greater than or equal to 1.
Yeah, it's greater or equal to 1 because the rank plus a nullity has to equal 3. Okay? Clear? Which means that the dimension of the vectors that you get over here can only be 2. Okay? So these vectors span only a two-dimensional subspace of R3. Okay? Follows immediately. Because the columns here all end up over here. Okay? And only sums of multiples of columns end up over here. Okay? Yeah, I could write that out explicitly, but we've talked about it sufficiently. Okay? So, that's it. Just going to bring up things around to rank and nullity. Okay? And you can do this for any linear transformation that's defined like this. Okay? That's defined in terms of a function like t of x, y, z.